All right, so for Form A, we're going to start off. We have an angle, a central angle that's 35 degrees. The center is the point -3, 2, and we have a radius of 4. So first, we're going to go ahead and start with finding out what the arc measure of AB is. And so our arc measure is going to be the same thing as our central angle. So that means this is also going to be 35 degrees. So measurement of arc AB will be 35 degrees. Then we're going to go ahead and convert 35 degrees to radians. So that would be taking 35 and multiplying that by pi over 180. Oops. And so then after that, when I multiply these together, I can divide both of these by 5. So 180 divided by 5 is going to give us 36. So that's going to be equal to over 36. And then 35 divided by 5 is 7. So 7 pi over 36. So that's just simplifying that down. So my previous answer in radians would be 7 pi over 36. Next is asking for the measure of arc ACB. That's our major arc that goes around the outside here. And so that would be 360 minus 35 degrees, which is going to be 325 degrees. So that would be 325 degrees. And then my next angle it's asking me for is going to be angle ACB, which is our inscribed angle right here. So our inscribed angle, if we remember the definition, is going to be half the measure of our intercepted arc. So 35 divided by 2 is going to give me 17.5 degrees. So that would be 17.5 degrees. All right, here's the part where it starts to pick up a little bit. We have our length of AB and the area of a sector of sector APB. Oh, APB, which P is the center. And we're going to leave these both in terms of pi. So AB, the length of this, we're going to use our radian measure we have here because that's going to be easier for us to go ahead and solve for, because the formula generally for finding arc length is pi r, or 2 pi r times theta over either 360 or 2 pi r times theta over 2 pi. Now, when I go ahead and simplify these in radians, this will simplify all the way down to just r theta, which I believe is a lot easier to solve for than going ahead and doing pi r theta over 180, which is a simplified version of degrees. So r, which we already know is going to be 4 times theta, which is going to be 7 pi over 36. So that would just leave us with 4 times 7 pi over 36. Uh, 4 times 7, that will be equal to 28 pi over 36. I can divide both of those by 2. That would give me 14 pi over 18, which I can divide that by 2 again. That would give me 7 pi over 9. So my length of AB is going to be equal to 7 pi over 9. Next, we're going to find the area of that sector. And again, I'm going to do this in radians because just like with degrees, I think it's a little bit easier to do in radians, because that equation there was going to be pi r squared theta over 2 pi. And I can go ahead and get rid of my pi's here. So it's just going to be r squared times theta over 2. So r squared, that would be 4 squared times theta, which we said is 7 pi over 36 divided by 2. And I'll go ahead and I'll simplify that now. So 4 squared is going to be 16. 16 times 7 pi over 36 times 1/2, the same thing as dividing by 2, which will equal 16 times 7 pi over 72. So I can simplify this down now further. 72 and 16. I can divide both of those by 2 to give me, what is that? 8 times 7 pi over 36. And I can divide that by both of those by 4. So 8 divided by 4 is going to be 2 times pi over 36 divided by 4, which is 9. So I'm going to be left with 2 pi over 9 as my area of my sector. So 2 pi over 9. And so that would be my final answer, leaving it in terms of pi. And then lastly, if I'm just going to go ahead and write the equation of the circle in standard form, I just have to use my point and my radius. So my center point is -3, 2. So that's going to be x plus 3 squared plus y minus 2 squared, because it's the opposite of what we have inside our parentheses, is going to be equal to our radius squared, which is 4 squared, which is 16. And then lastly, we're going to go ahead and complete the square. To solve this, I'm going to organize these together as well as putting my y's together, and then move this 9 to the opposite side by subtracting 9 from both sides. So that will end up giving me x squared plus 12x plus y squared plus 6y is equal to -9. Then I go ahead and I complete the square for each of these respectively. So that would be x plus 6 squared minus 36, and then that would be plus y plus 3 squared minus 9 is equal to -9. I'm going to add 9 to both sides as well as adding 36. And then so that will give me the final equation of x plus 6 squared plus y plus 3 squared equals 36, because the adding 9 to this side will cancel that out, and I'll just have a 36 left over. So that would be my equation of my circle using completing the square.